Let us discuss the sampling method for performing maximum power point tracking. One can do voltage sampling or even the current sampling. One should note that in the case of the reference cell method, a reference cell is used and it is either open circuited or short circuited depending upon whether it is Im by ISC kept constant or Vm by VOC kept constant. In the case of the reference cell, this is expected to represent the actual PV array. But if the array is big and it covers a large amount of real estate area, then the reference cell doesn't actually represent the entire array. So in cases when there is partial shading due to neighboring building, the shading due to trees nearby, the voltage that the reference cell gives will not actually reflect the voltage that is supposed to have been obtained from the actual PV array or the PV module. Same with the case of current scaling also. Now the question is, can we eliminate this reference cell and then can we get a signal which will represent the VOC of the actual array, which is PV array, which is delivering power to the load. If we are able to do that, then we are one step closer to a much more accurate MPPT algorithm. Let us now look at how the sampling method is done to perform maximum power point tracking. PV panel is connected to a DC-DC converter and the DC-DC converter output is connected to R0 as shown. In between here there is a switch, but before that let us place this buffer capacitor, which we are now familiar with, and this is a switch. I will include that. The switch has a name S and it has two throws. It's a single pole double throw A and throw B. When S is connected to throw B, then that is the normal operating condition when the PV panel is powering the load through the DC-DC converter. When switch S is connected to A, B is open and whatever energy is stored in this buffer capacitor will be driving the load. And across this resistance, the sense resistance, it's a high value resistance. So the voltage across this resistance will approximately be equal to the open circuit voltage of the panel. And that is precisely the time when it has to be sampled and taken as the open circuit value. So that precisely is what we will be doing in the sampling method. Let us call this resistor RSA and we will sample this potential. If the switch is not connected here, if it is connected to B, then this potential will be 0. If the switch is connected to A, it will be VOC value. Let us connect it to a sample and hold circuit. The output of the sample and hold circuit will be VOC. And where do you get VT? The voltage across this buffer capacitor will give you the actual array. So let us say that is also passed through another sample and hold. We will get VT, the terminal voltage, what is expected of the array. Now, when will this switch be connected to A and when will it be connected to B and for how long? Let us draw a time axis T and I will mark a tick, let us say, and let me place a rectangular pulse, and during this pulse this switch will be enabled and connected to A. So during this time, this sample and hold circuit for VOC is enabled and effective. And next again, after certain time has elapsed, you will repeat it once again, and so on. It keeps continuing. So this pulse duration during which, the shaded pulse duration during which S is connected to A to sample VOC is very small, so that there is sufficient charge here and the load doesn't miss the disconnection of the PV panel at B. So normally this is having the time duration of the order of 1 microsecond or tenths of microseconds, and this duration, majority of the duration when S is connected to B is very large. It is of the order of seconds. So this will be of the order of seconds. So you will see that this switch is controlled by a duty cycle ds, and then this ds is 1 microsecond by 1 second, which is 10 to the power of -6. So it's a very, very small duty cycle. So we will get the value of VOC, and then if you then pass it through ADC, it can be taken to the digital domain. And because of the presence of this buffer capacitor, during this very small duration when S is not connected to B, the buffer capacitor will supply to the load. Now this is called the voltage sampling method. So once VOC and VT are sampled, basically the control block diagram for achieving maximum power point tracking will be same as what we had discussed in the reference cell method with voltage scaling. Let us also look at current sampling. So just like in the voltage sampling, we need a PV panel connected to the DC-DC converter, a buffer capacitor, and then connected to the load like this. And then we have a switch. Now the switch, when it is connected to A, we don't use a resistor now, it is just a short circuit. So when S is connected to A, the panel is short circuited. So any current that you measure here will give you the short circuit current. So let us say I measure that current through a Hall sensor, pass it through a sample and hold, and the value that I would get there would be ISC, the short circuit current at that instant of time, whatever the insulation at that instant of time. Now if I have to get the panel current, I can sense here and average, pass it through an averager, and I will get IT. Now if you look at, similar times can be used for the current sampling method also. So let us say for 1 microsecond S is connected to A, and for 1 microsecond the PV panel is short circuited, and the current that is measured, sampled and held will be ISC value at that instant. Then it is released and the load is connected, and for majority of the time what is flowing here would be IT, and for that 1 microsecond time what is captured here by this circuit is ISC. So when you pass it through an averager, it will average out that 1 microsecond, for that 1 microsecond the unnatural short circuit current that will flow through this. So you will effectively get, because the duty cycle is very low, so you will effectively get IT, because majority of the time what is flowing here will be the IT average. So this is called current sampling method. So once you have sampled the current, the block scheme is essentially like what we discussed in the reference cell, except that this is no longer there. ISC is coming from the sample and hold. IT here is again coming from another block, which is the averager block. So IT is given here, ISC is given here, scaled appropriately, you will get IM. And then the functioning of the maximum power point tracking control algorithm will be similar to what we had discussed in the referential current sampling method.